Alright, in section 8.4 they talk about other functions. So these are the 5 different functions that they basically talk about. First one is the line, we've seen that before. This one's x squared, it's a parabola, it has one change in direction to it. This one's a cubic, it has degree 3, so it has 2 changes in direction, so it changed there and it changed there. And then absolute value has that sharp edge to it, okay, with that one sharp edge to it. And then 1 over x, okay, 1 over x looks like this guy here, okay, that's called a rational function. Okay, so now they talk about, first thing they talk about in 8.4 is they talk about the number of deaths according to AIDS by year from back in 1980 to 2010 it looks like. And the numbers increase, but then they start to still increase, but they increase at a slower rate here. Okay, and so the numbers are not linear. It's clearly not a line. It's got a curve here, and it starts to curve the other way there. So it's a complicated function. It's not clear what it actually is, linear or line-wise. So now we talk about domain and range, but we talk about using interval notation to describe it. So when you see a line, it's all real numbers, minus infinity to infinity. Now if you see square root, you force what's under the square root to be not negative, so greater than or equal to 0. And when you solve it, you get t greater than or equal to 1. So your interval is 1 to infinity. Now if you have a fraction, you set the denominator equal to 0, and you get v equal negative 3. And you got to throw out that number. Minus infinity to positive infinity without including minus 3. So you write it this way, 2 separate intervals with the union symbol in between. Alright? And now this one goes from 0 to 2, so that's your domain, and it goes from minus 4 to 4, and that's your range. Again, squish it on the x-axis for your domain, squish it on the y-axis for your range. Absolute value function, if you don't know it, absolute value takes away a negative sign. So if this is negative, absolute value of a negative is just the positive number. Same thing here, it's just a positive number. But if it's already positive, it doesn't change the answer. Absolute value doesn't do that. Okay, now how do you evaluate a function? Well, this one's a cubic, 4x minus x cubed, and you can graph it like this, and you can see what the graph looks like there. Okay. Now, what about evaluating these different functions for these different values? Well, you just plug in that number into the function. So remember, you say f of blank equals negative 3 times blank to the 4th subtract 2. And then negative 2 times blank cubed minus 4 times blank squared plus 5, and you plug in the minus 3 where you see a blank. And then you just multiply it out. Alright. This one talks about the heart rate of an athlete, and it gives you a quadratic for this guy. And it says find the initial heart rate, meaning at time 0. So you plug in 0 there and you get 200. Okay? And then what about after 8? And 8 is the heart rate after 8 minutes, and it's 80 beats per minute. So after 8 minutes it's 80. And the heart rate does not drop at a constant rate, rather it drops rapidly at first and then starts to gradually level off at a certain point. And then you've got the rational function. Rational function is a fraction of polynomials. Okay? It's one polynomial divided by another polynomial. Okay? And you've got to watch out for dividing by 0. So in this one you can't let x equal 0. Here you can't let x equal, well, x can be anything here. This one you can't let x be 3 or minus 3. So when you graph something like this one where x cannot equal 2, it's undefined at 2. That's why it's got a dotted line there, and the graph does not actually cross that line because it's undefined there. So it's going to shoot off in this direction, that direction. It's got this thing called a vertical asymptote. Okay, the vertical asymptote is where the denominator equals 0 at x equals 2. Alright, so write the domain for each one of these. So this guy is going to be everything but negative 2. So your domain is minus infinity to infinity, throwing out the minus 2. And this one, if you factor the bottom and set it equal to 0, you get 1 and 2. So you got to throw out 1 and 2. And this one, you factor the bottom and set it equal to 0, and you're throwing out 0, 1, and minus 1. So you're throwing out a whole bunch of numbers there. Alright. If you want to graph a rational function, you can just use a table of graphs, and notice at 0 it doesn't give you a value because dividing by 0 is undefined. And that's what the graph looks like. If you want to graph this guy here, or this guy here, and this guy here, this is the table, this is the formula, and this is the graph. And when you plug in the -1, 1, or 2, you get these different answers there. Notice when you plug in 1, it's undefined. You don't get an answer. So you write does not exist. Right? So f of 1 is undefined, and so input 1 is not part of your domain. Right? So you notice at 1, it does not have a value. Right? And I don't think we need to really worry about the rest of that stuff. Alright, so let's look at the similar questions. So question 23 says, h of x equals absolute value of x minus 1. What does the graph look like? Well, the way you graph an absolute value, by the way, is you gotta hit y equals, hit clear. You gotta go up and turn the plot one off. Okay. Now how do you type in absolute value? You hit math, arrow to the right once, and then type a 1 in. And that'll give you the absolute value bars. And then you type in x subtract 1. And now that's what your graph looks like, and if you zoom 6, there's your graph, which is what we got here. And so this guy actually moves over 1 unit. It should have crossed here. Yeah, it doesn't cross at 0, 0. Right? Now this one, 1 over x minus 1, you can graph that one pretty easily. 1, divide, and you got to put x minus 1 in parentheses. Right? You got to put x minus 1 in parentheses, otherwise it doesn't know that you want the x minus 1 in the denominator. So now when you hit graph, looky there, it shoots off in both directions and it is not defined at x equals 1. And if you do the same thing with this one, you find that it's not defined at 2, and also it's not defined at 1.5. Up here, this one was not defined at 1, and here it's not defined at 0. This one's a line segment, and it goes from -2 to 2 and -1 to 3. So that's your domain and that's your range. Again, squish it on the x-axis, squish it on the y-axis, and that's your domain and your range. Same thing here, squish this on the x-axis, you get -2 to 2. Squish it on the y-axis, you get -2 to 2. Same thing. 42, this is going up and to the left forever and up and to the right forever. So this is -infinity to infinity for the domain. Okay. But your range, it only goes as low as -3, but it goes up to infinity. So -3 to infinity. Okay. Now they ask you if something's a polynomial. If it is, what's its degree and what type of polynomial? Well, this is a polynomial. Polynomials have x's. They can have many x's, and the exponent of each one has to be a positive whole number. Can't have negatives or decimals. Right. So 5x minus 11, that is a polynomial. Its degree is 1. The degree is just the highest power of x, which is 1 here. And it's a binomial because it has two terms. 5x and 11 are each individual terms, and there's two of them, so it's binomial. If it had 3, it would be trinomial. If it had 1, it would be monomial. Right. So now this one, they ask you to plug in -2 and 4 for this, so you use g of blank equals 3 times blank squared minus 2 times blank, and you plug in -2 into there and you get your answer. Same thing here with 4, you plug that in. Same thing here, you plug a 5 in there for t, and t, and you get 5 over negative 5 over 5 plus 1, which is negative 5 over 6. This one you plug in a -1 and you get 0 in the denominator, so that means that's undefined there. Okay, so you don't get an answer for that one. Right? And so then f of -1 is positive 2. Look at that, -1 gives you positive 2. And also if you use the formula, you know the formula is x squared minus 3 here. When you plug in -1 in there and simplify, you get -2, and if you see the graph, you get -2. And at positive 2, you see that you get positive 1 there. Or if you plug it into the function, you get the same thing. And the same thing here, you're plugging in -1 or positive 2, and you get these two answers here. This one they ask you to graph it, and so you should graph x squared minus 2. Okay, so x hat 2. Get an arrow out of the exponent, and then subtract 2. And now when you hit zoom 6, that gives you a graph. Okay, and if you want to graph some points, just hit second table. And there's a bunch of points there. You can do minus 2, 2, minus 1, 0 and minus 2, 1, minus 2, 2, 2, 2. And so you get these numbers here. And then you can graph it. Okay, this one says the speed wind during a day that is initially calm becomes windy and then is calm again. So as it becomes windy, the speed of the wind would increase. Here the speed is very high and it's decreasing. That's not it. Here it's low and it's increasing. That's not it. Here it's low and increasing. That's not it. It's low, increases, and then decreases. So it has to be A. Right. In 13, they ask you to find the domain and range. Well, the domain, it goes left and right forever, so it's minus infinity to infinity. Range, it goes from up and down forever, so minus infinity to infinity. 17, it goes to left and right forever, so it's minus infinity to infinity. Your range, on the other hand, is 2 or larger, so bracket 2 to infinity. 21, when you graph this, you can see that your domain is minus 1 to infinity, and your range is 0 up to infinity. Because it's going up slowly, but it is going up forever slowly. Right. 57, you want to plug in 1 and minus 3/4 into the function, and when you do, you get these numbers, and you drop the negative sign when you do absolute value. And here you plug in a 2 or a minus 2 into the function, and you get these two different values here. Okay. And then 83, you graph that. You can graph absolute value. Remember how to do that? You hit y equals, and then you type in, you want to hit math, arrow to the right, 1. And that gives you absolute value bars, and you just type in x plus 2. And now when you hit zoom 6, it gives you a typical window there, and that's what it looks like. Then 1/2 x squared, you can graph that one. You can type in 1 divided 2, x hat 2. It gives you 1/2 x squared. And that's what it looks like. And again, if you want to see the table values, just hit second graph, and it gives you all your table values. And there you go.